Thank you all. So what I will do is I'll do a quick introduction of Vint, and then I will move on to some activities that ISOC India Mumbai does as chapters, based on a comment from one of my colleagues. I've just switched off the light before me so that it doesn't sound too bright. But over here, so good morning, afternoon, evening, everyone, depending on where you are in the world as of now. Today, we are in the presence of a true legend and in the history as well as future of internet communication. Please welcome Dr. Vinton G. Cerf, known around the world as one of the fathers of internet. In 1970s, Dr. Cerf, who designed the TCP/IP protocols, laying the foundation of what would become the modern internet, a creation that has revolutionized how humanity connects, works, and lives. But his vision has not stopped at Earth. As chief internet evangelist at Google, and in collaboration with NASA and other agencies, Vint has been working on something once thought purely as science fiction, the interplanetary internet. This bold endeavor aims to create a network that can connect Earth to spacecraft, Moon, the Mars, and beyond, ensuring reliable communication across the vastness of space. Today, we are not just going to hear from an internet pioneer, we are going to glimpse the future of cosmic communication through his eyes. Please join me in welcoming the trailblazer who has helped humanity reach for the stars, Dr. Vinton G. Cerf.
Well, first of all, thank you very much for inviting me to join you today. Just for time zone purposes, it's about 8:30 in the morning here in the Washington, D.C. area. And I'm always a little embarrassed by these introductions because I'm not the only guy that contributed to the internet. There are literally millions of people by this time. And the same is true for the solar system internet effort. That activity has been going on for almost 25 years now. And just so that you know that, I'm going to be held to a very high bar, I'm going to introduce one of the other inventors of the solar system internet, who just happens to be here with me this weekend, and he's monitoring my presentation to you. And so he may leap in at any moment and tell me I've got the wrong idea. I'm going to rotate my slides around here, and there is Scott Burley. Scott is one of the primary authors of the delay and disruption tolerant networking protocols. He's formerly at NASA for a long time. He's retired now, but he's still very active in the Interplanetary Network Special Interest Group, which is the interplanetary chapter of the Internet Society.
No worries, Vint. Thank you for that brief background on Scott and a lot of other people. And, we really acknowledge the great work which is done by everyone on this topic as well. So, we might have missed a few names based on our lack of knowledge, but, we take that in our stride, and we are going to even, acknowledge the great work which has been done by all these people as you work on this topic. I just wanted to ask if my presentation is visible, so I'll just quickly move through what ISOC Mumbai does as a chapter.
Yes, it is.
Yes, we can see it.
Yeah. So quickly, we are the Mumbai chapter of Internet Society. We are also shaping the future of the internet in our own way. We are an ICANN at-large structure. Our vision basically stems from the fact that we want to improve the digital capabilities of people in Mumbai. We want to ensure that the internet is preserved in sense of its security as well as design. And we want to create an internet which not only connects networks, but also connects hearts and people. We are trying to create a humane aspect of internet in our own ways. As a chapter, we have executed more than 100 events, impacted 50,000 plus lives, and have had our own set of publication at ISOC Mumbai. A unique thing, So a unique thing about us as a chapter is, as of now, we are the world's only all-women-led ISOC chapter, and we are one of the only chapters that represent the user interest of Western region of India. Just quickly running through our leadership team, our fabulous all-woman leadership team who runs the ISOC India Mumbai chapter. Nupur, we have Juisha, we have Jigmit. In addition to the current leadership, we have an entire category of past leadership, which includes people like me, Shweta, Nandita, Priyamvada, who have played a critical role in this running of this chapter. ISOC Mumbai chapter is a global chapter, so we not only have volunteers who are based in Mumbai, India, but we have volunteers across the globe covering more than 25 Indian provinces and 20 plus Indian countries. Here is a glimpse of some awareness and capacity building initiatives that we have worked on. We have organized events for veterans. We have worked with Wikimedia Foundation. We have, introduced the importance of internet to underprivileged kids. We have organized events of multilingual internet and organized roundtable discussions. We are also an important contributor of something called as the India School on Internet Governance. Here are just some of the photos of ISOC India Mumbai volunteers working across the India School of Internet Governance at different instances of time. We also participate in international workshops and assembly meetings. We have participated in ICA in Montreal. We have participated in trust workshops organized by ISOC and are also an Atlas member at various Atlas workshops. We also run our own newsletter. So the concept of heterotopia, which comes from Mikhail Foucault, we encourage different individuals to talk about their own version of internet, about how they are going to use internet and technology in a specific area and how they are going to take it to the next level. So we also run our own intra-chapter newsletter called as Heterotopia. Heterotopia newsletters are well regarded for taking opinions from a variety of people. And we also ensure that we have an excellent design being made whenever we come up with a newsletter. We also have our own chapter specials, wherein we wrote on an internet of talent. We have written a newsletter on INSIC, wherein we come up with special events or topical issues that ISOC India Mumbai as a chapter focuses on. We do a variety of online events on things like manners. So something as technical as manners to something as how do you teach internet governance to Buddhist monks? So, whether you can reach a Zen mode. So we cover a variety, we take internet as a concept and try to, contextualize it to various target audiences across the globe. And we also have, because we have a women-led chapter, we also have a specific leadership series called as Women in Technology Leadership Series, wherein we invite prominent women in tech to come and encourage our chapter volunteers. We also have another event called as the Budding Polymath, wherein we give young individuals opportunities to build their public speaking skills as well as their technical speaking skills. So it's not only about knowing about the internet, but also about how you communicate those complex technical concepts in an easy to understand manner is something that we work on. So with this is the end of our short presentation. Vint just kind of gave you an idea of who we were as a chapter. We were set up 7 years ago. We run our own newsletters. We do a variety of events for local audiences. And we have our own initiatives which are dedicated for women and our youth volunteer. So with this, I won't take much time away from you, Vint, on this. With this, I will request you to now take the floor and speak on this topic of importance. So thank you, Vint, for your time.
Well, thank you very much. That was a fantastic introduction. I even took a few notes. The Interplanetary chapter has about 1,000 members, and of course, it's more than global in scope. Theoretically, if we ever get any Martians, we'll be happy to have them join the Interplanetary chapter too. I want to congratulate you, though, for the level of activity that the chapter has demonstrated. And I want to encourage you to apply to the ISOC Foundation for support. The Internet Society is expanding its philanthropic footprint very significantly. And so Christopher Locke, who is the executive director of the ISOC Foundation, or managing director, would be happy to hear, I'm sure, from you and others about projects that you're looking for support. So with that, I'm going to pretend to figure out how to get my screen back up again for this presentation. Here we go. Theoretically, I am showing you a full screen. Can I get confirmation that you're seeing my screen?
Yes, we do.
Okay, that's great. So this topic is about the solar system internet, which is a natural extension of the original terrestrial internet. And this all got started shortly after the successful landing of the Pathfinder mission on Mars in 1997. Some of you will remember, or at least have read about, an earlier mission called the Viking mission. There were 2 Viking spacecraft landed on Mars in 1976 with a very successful mission. A lot of data was returned. And then for some 20 years, it seems like nothing worked. You know, we missed the planet, or we burned up in the atmosphere, or we crashed on the planet. And then finally, in 1997, the Pathfinder mission landed successfully. And of course, we were very excited about that. They landed the rover, the little Sojourner rover, in a bouncing balloon. And I can remember thinking at the time that if I'd been the program manager for this project and the engineers had come into my office and said, we're going to deliver your $6 million rover in a bouncing balloon, I would have thrown them out of my office. But it was a very successful landing. And that got me so excited that I got together with the Jet Propulsion Lab team that handled communications for this Pathfinder mission. And within minutes, we started contemplating what should we be doing then in 1998 that would be significant 25 years later. And we decided designing and building an interplanetary communication network to support manned and robotic space exploration should be our target objective. And so since 1998, this effort has been unfolding. Several other missions have landed since the Sojourner Pathfinder mission in 97, and most significantly, the 2004 landing of Spirit and Opportunity really opened up an entirely new chapter in Mars exploration. And subsequently, there have been many other missions that have been successfully executed. So when we were getting together thinking about this, we got to discussing what some of the challenges would be in building a solar system scale internet. Near Earth, we have an awful lot of debris from previous missions from the various satellites that are being launched. And of course, there are literally planned to be tens of thousands of satellites in the Starlink system and others. So already there's a lot of space debris that we have to worry about that can interfere with getting things off the planet. And then there are coronal mass ejections that can occur off the sun, and those could have extraordinary impacts, especially if they hit Earth. You get what in effect is an electromagnetic pulse, which can interfere with all kinds of communications capabilities. Radiation in general is a hazard, especially for electronics. And there's plenty of radiation within the solar system to interfere with the electronic packages that are needed. And then there's a couple of little physics problems. The distances between the planets are literally astronomical. And if you do the math, you discover quickly that the speed of light is too slow to make certain protocols work well. I'll come to that in a minute. And then there's this problem of the planets rotating, which we don't know how to stop. So if you've got something on the surface and you're trying to talk to it and the planet rotates, you can't talk to it till it comes back around again. Same problem happens with satellites that go behind the planet, and planets go behind the sun. And so we're in a highly variably delayed and disrupted environment. And that informed our thinking about how a solar system internet could work. Why am I not getting? There we go. Oh, I'm suddenly not able. There we go. So when we met in 1998, our first thought was, well, we've got this TCP/IP protocol. It was developed 20 years before, and it seemed to work on Earth, so it ought to work on Mars too. Then we started doing the math, and we realized that the round trip time to Mars when we're farthest apart was 40 minutes, and the TCP flow control didn't work very well. with that kind of round trip time. And DNS lookup didn't look very attractive either. Imagine that you're on Mars and you're trying to get to some website on Earth, and you do a DNS lookup. 40 minutes later, you get an IP address. The problem is that in that 40-minute period of time, maybe the destination is mobile and it's adopted a different IP address since the last time you looked. So the delays and the disruptions suggested that the TCP/IP protocol suite simply would not be suitable for doing deep space communication. So we decided that we had to re-examine space communication in the context of delay and disruption. We labeled this delay and disruption tolerant networking, or DTN, and developed a protocol suite, which we call the bundle protocol. It has a number of different features. It's a layered architecture in the same way that the TCP/IP protocols are layered. We concluded that first you had to figure out which planet you were going to, and then after you got there, then you could do a name lookup if necessary in order to figure out where to actually go on that destination planet or spacecraft or moon or asteroid. Second thing is that because the delays are so significant and the distances are similarly, that it made sense to actually store information in the network if necessary. So to give you a concrete example, suppose you're going to communicate with Jupiter and there's a relay on Mars, and you get to the Mars relay and you deliver your data, which is now supposed to be forwarded to Jupiter, and the Mars relay says, I can't see Jupiter right now, you're going to have to wait. In the terrestrial internet, we actually throw things away rather than storing them in the routers. It makes no sense to throw things away after you've gone all the way to Mars. And so we actually store things in the network, in the forwarding routers, until the next step or next hop is available, and then we forward it. Now that introduces all kinds of challenges, including congestion control and memory management and things like that, which are more severe in some ways than they are in the terrestrial internet. Also, network management is not quite what it used to be. In the internet world, at least in the early days, we made use of a protocol called ping, which basically said, please send me, echo this packet so I can confirm that I got to the destination is live. Well, ping could take anywhere from 7 to 40 minutes to come back to you if it comes back at all. That's not a very interactive and responsive kind of network management. Since that time, things like NetConf on the terrestrial internet have been developed, which are very similar to the ideas that we've adopted for the interplanetary protocols, where you send a batch of instructions to a target relay, and the target relay absorbs those instructions and executes them. So you don't have to have a lot of handshaking in order to accomplish network management. So in a way, both the terrestrial internet and the interplanetary internet have evolved in similar directions, where the network management system is not quite as chatty as in the earlier designs. And finally, we were very concerned, given that the assets for space communication would be relatively modest in terms of connectivity and numbers. We wanted to make sure that only authorized parties had access to the facilities of the interplanetary system. So we decided to build into the protocols, the bundle protocol suite, very strong authentication and also encryption as part of the normal operation of the system. We have those capabilities in the terrestrial internet, but they were added on later in its evolution. Here we are putting them into the center of the system, recognizing how important it is to have only authorized parties using the potentially limited assets of the solar system internet. Just like the terrestrial internet, we believe strongly in standardization, and there are two entities that have assisted with that. One is the Consultative Committee on Space Data Systems, which is responsible for adopting standards for space communications and has been around for some decades now, doing exactly that. And then, of course, the Internet Engineering Task Force, which had its first meeting in 1986 and was spun out of the earlier Internet Architecture Board. And that is also a place where Internet standards have been made over the course of decades. Both of these organizations have in parallel adopted standards for the interplanetary communication system, and that has given us a strong foundation for the adoption of these protocols. So the internet itself, of course, looks something like this, just to give you a sense for many, many thousands of backbone networks all interacting and cooperating with each other. We've taken lessons from the internet. One of them is standardizing the protocols so that everybody can interoperate. The second thing is that we use open forums for the standardization of existing and future protocols. And third, we believe in multi-stakeholder governance of these systems, where all the parties who are affected by the internet have a say in how it is governed. And we think those principles should be adopted for the interplanetary equivalent of that. We are looking forward to a solar system internet, which uses the bundle protocol suite for space communication that is collaborative with regard to its governance and uses open forums for standardization. And in particular, the CCSDS and the IETF are the two that we have exercised our standards work in. We started prototyping in 1998, and when 2004 arrived and Spirit and Opportunity landed, the original plan was that they would transmit data back to the Deep Space Network. That's a network of 3 70-meter dishes located roughly 120 degrees apart around the planet in Canberra, Australia, Madrid, Spain, and Goldstone, California. The data rate that we could sustain from the surface of Mars was approximately 28.5 kilobits a second. And the scientists were not very happy about that, but that's pretty much the best you can do when you're talking literally tens of millions, if not hundreds of millions of miles of communication. It's my understanding that when we started transmitting data from the rovers, the radios were overheating, and the engineers said we had to back off on the duty cycle, which made the scientists even more unhappy. But there was an engineer at JPL who made the observation that there was an X-band radio on board each of the rovers, and the orbiters, which had been sent earlier to map the surface of Mars to figure out where the rover should go, were still in operation. They had communications capability, they had electrical power with solar panels, and they had computing capability. And so it was proposed that we would upload a prototype suite of software called CCSDS File Delivery Protocol to those rovers and to the orbiters that were in orbit around Mars, and then essentially use the file delivery protocol to move data from the rovers up to an orbiter when it got to the right place in its orbit. We would store the information in the orbiter, and then the orbiter would hold it until it could transmit data back to one of the Deep Space Net receivers. And that particular system has been in use since 2004. So over 20 years now, all of the rovers that have landed have been using this store and forward system, which, as all of you know, is packet switching, which is the basis for the terrestrial internet and is also the basis for the solar system internet. So all of those rovers that have landed, plus the orbiters that have been in place, have been using this prototype software in order to communicate data back to Earth and to accept commands from Earth. In the interim period since 2004, many different tests and experiments and demonstrations have been done. Evolution of the protocols has happened. We are all the way up to bundle protocol version 7 now, which we've standardized on and hope to settle on for further evolution of the solar system internet. I don't propose that we go through every one of these bullet points in detail, but I want to point out that among the various tests that we did, first we wanted to make sure that it actually worked at distance. So we had this epoxy test at 81 light seconds away. We uploaded our protocols to the spacecraft that had visited two comets with the permission of NASA, and then transmitted our data back and forth using our bundle protocol suite. We also have been on the International Space Station since 2009. We keep upgrading the implementations to the current bundle protocol version 7. So the crews on board the International Space Station have been using the bundle protocol suite for communication since that time. We also performed a real-time experiment because the protocols, although they're designed to deal with highly variable delay, they are also intended to work in real time if the delays are small enough. The International Space Station is only a few hundred miles away from the surface of Earth, so the transmission times at the speed of light are quite low. And as a result, we were able to show that an astronaut on board the International Space Station could literally drive a rover on the surface of Earth in real time because the latencies were low enough. And then we also wanted to demonstrate that these same protocols would work at super high speeds. And so we've also participated in tests using laser communications between Earth and an orbiter around the moon at 622 megabits a second. So we persuaded ourselves that these protocols will work both at great distances and also at both high speeds and in real time when the physical parameters permit. We've also been working together with other space agencies like the Japanese Space Agency, JAXA, on implementation of the interoperability of the Interplanetary Overlay Network implementation. The author of that is Scott Burley, whom I introduced to you earlier and is with me literally as I speak. It was his pen on paper that eventually led to the ION implementation, which is certainly by far the most robust and most broadly capable implementation of the bundle protocol suite. We have continued to evolve the implementations and the testing, and as I say, we're now at version 7, which we hope to treat as fully standardized. We're still working with the Consultative Committee on Space Data Systems. We've also developed other protocols as part of the suite, one of which is the Licklider Transmission Protocol, which is a link layer protocol, which provides for reliable communication over a single hop. And then in a completely unexpected development, an engineer up in the northern part of Sweden, in Luleå, proposed and implemented bundle protocols to keep track of reindeer who were wandering around in the reindeer herds and managed by the Sami reindeer herders. So he'd been hanging GPS receivers around their necks and having them transmit using this DTN protocol where they are, and they keep track of them that way. That operation has been going on since 2008, and it has evolved over time to be more and more robust using higher speed protocols. So that was an unexpected use of the delay and disruption tolerant networking system. We've created the Interplanetary Network Special Interest Group, otherwise known as the Interplanetary Chapter of the Internet Society. We've been collaborating for years now with the European Space Agency, the Japanese Space Agency, and the Korean Space Agency. There are multiple implementations of the bundle protocol suite. I've just listed a few here. The most robust and biggest of which is the ION one that I mentioned earlier. And of course, we have expectation that we will be part of the Artemis return to the moon missions, the Gateway missions, and others that are on their way. We're starting to look at both terrestrial as well as extraterrestrial applications of the bundle protocol suite. So we're looking forward now into the future, not too distant future, where we expect to see sustainable activities on the lunar surface. As you all know, NASA has already invited commercial implementation of rovers and mining facilities, habitats, and laboratories, which they will purchase commercially from suppliers. So Intuitive Machines has landed 2 devices on the moon in the last several months, or I guess the last year or so. Others are also landing equipment on the moon. The Chinese are very active in doing the same thing. If I remember correctly, India has also managed to land facilities on the moon. And if they haven't done so, I'm sure they will soon. So we are expecting activity on the moon to pick up dramatically in the course of the rest of this decade and the next one to come. And of course, we are working very closely with regard to the Artemis return to the moon missions with our partners at ESA. They have a Moonlight communications mission. NASA has something called LunaNet, and the intent is that these will use the delay and disruption tolerant protocols in an interoperable way. Of course, in the longer term, we expect to see a larger number of participants building components of the solar system internet. But this raises a whole bunch of policy issues that I think all of you should be aware of and to think about. Imagine for a moment that you decide to take NASA up on its offer to buy the output of a mine on the moon. And you decide, okay, we're going to start a company and we're going to build a mine on the moon. And the CEO of the company says, can we own the property that the mine is on? And the legislators will say, well, no. There's an outer space treaty that was agreed in 1967 that said no one can own extraterrestrial property. Of course, this will cause the CEO a certain amount of angst because he's saying, well, if I build a mine on that property, who will protect me if someone interferes with my operation, if someone tries to take my claim away? Where do I register this? Who do I call if there's a problem? And there aren't any answers to those questions yet. And so those questions are no longer science fiction. Those are serious questions that we are going to have to answer. And some of you may actually be involved in helping us to solve those problems. The Artemis Accords, which are the agreements by which the Artemis mission will be undertaken by multiple parties, acts as a kind of prototype for the sorts of treaties that we might want to adopt across all of the nations of Earth as we begin to reach out into the rest of the solar system with both commercial and research exploration. The commercialization is underway already. People are offering, or companies are offering, to build communications facilities. They are hoping to put in relays and moon orbiters. They expect to build bases, or at least provide facilities for bases and mines, as I mentioned earlier. Some are building rovers. Some are even talking about putting small nuclear reactors on the moon, which, by the way, is actually an important consideration because the moon goes dark 14 days out of the month. And if the only thing that you have for power is a solar panel and a battery, it could very well be that your missions may die after 14 days in the sun because you don't have enough energy to last during the dark period. A small nuclear reactor might turn out to be an excellent solution, especially for a long-term presence on the moon. I've already hinted at the policy challenges, and this is going to take some very creative thinking and very adroit, I would say, negotiation on an international basis to come to agreements about what those policies should be. You know, are we really going to allow private property on extraterrestrial bodies? Should we? And if we do, under what terms and conditions? Where do you register? How do you deal with disputes? What about crime prevention? What about the notion of sovereignty? Many of you, I'm sure, are very familiar with the 1648 decisions that led to the end of the 100 Years' War, among other things. And those treaties essentially established the concept of national sovereignty, that a country is sovereign within its borders and no one else has authority within those geopolitical borders. But what does that mean in space? And should we change our concept of sovereignty? What about other rules where salvage rules, for example, are codified in the treaties on Earth with regard to the oceans, especially the international portions? And what about the obligations to render emergency aid? That's incorporated in the Artemis agreements, where anyone who signs the agreement says if someone else is having a problem, we will respond. We have a huge worry about the potential militarization of cislunar space. The risk factors are already quite evident. And we don't really want to see militarization of the rest of the solar system if it could possibly be avoided. We have a space force in the United States, and it's possible there are other similar things in other countries. It's not quite clear what their roles and responsibilities should be. What about contamination on the moon and on the other bodies of the solar system? Should we establish heritage sites for where the space landing on the moon in 1969 might be a preserved site that nobody is allowed to mine or interfere with? These are all considerations that are immediate concern because we are returning to the moon in the next couple of years. I just have a couple of other slides and then we can go to Q&A. I mentioned sovereignty already. We really do have to understand exactly what does national mean when we're speaking in the context of the solar system. The Westphalian agreements in 1648 worked okay on one planet. The Antarctic model doesn't quite work. Many of you may know that Antarctica is treated as a special place on the planet, but there are territorial claims for portions of Antarctica based on projecting lines on the, what do I want to say, lines of latitude and longitude. Those lines have been used to make claims by different countries to various parts of Antarctica. All of the countries that have those claims have agreed that they will withhold from trying to enforce the claims. So the Antarctic is an international region. It's not clear that we should try to adopt a similar practice for the moon or Mars or any of the other planets. For one thing, there are no countries on them to make any claims in the first place. So that model probably does not work. Will we need new institutions? I think absolutely. Will they be multilateral? I think they have to be. Will they be UN-based? I don't know, although there is an organization called UN COPUOS that is concerned about space agreements within the context of the United Nations. So that's not a bad place, perhaps, to start. How will we deal with disputes on other planets? What kinds of arbitration? What regulatory models? Well, look, you can add to this list. It's a very long list of issues. Some are immediate because of the return to the moon, and some are in the more distant future as commercialization expands and as the population of Earth begins to expand off planet. So many of you are going to live through some of these issues because you're a lot younger than I am. I may not see many of these, but it's been a great privilege to even think about them because it's transforming science fiction into reality, which of course is what engineering is all about. So I will stop there. Thank you for your attention. And I'll also stop sharing so that we can have a reasonable conversation. And I thank you again for your attention.
Thank you, Vint. It was an exhilarating presentation, understanding the nature of interplanetary internet, right from spacecraft to herding deers, and now up to Artemis records. I think there is quite a fascinating journey and a wide variety of aspects that we are covering. And you also highlighted some very interesting policy issues out for us, with different models. For a lot of us, this is our first introduction to this intense topic, and we will take some time to go back and reflect on it. But meanwhile, we will move over to some questions, and in case if anyone has some questions. So what I request is if anyone has questions, you can please raise your hands via Zoom, and we will get back to you for a question or two. So if there are any questions, please feel free to ask. Please raise your hands. You can also put the questions in chat as well.
Yes, I am monitoring the chat. So
yeah, you're also looking. Anup, you have a question? Please go ahead.
Hey, thank you, panel, for letting me ask the question. Hi, Vint. This is Anup. So I'm also trying to establish Digital Peace Day So one of the key reasons for this question is, like I see there are many laguna into the policies that internet needs to be governed by, like in the realm of telecommunication, or there are many. So how can we put up these things to a platform, maybe via you or maybe via internet society, so that this laguna can be overcome and a global policy takeover can be looked, so that these lagunas are fixed. This is one of the things. And further, if these policies are, I would like to take your answer on this, then I would go with the second one.
So, all right, yes, thank you. The older I get, my push down stack gets very, very short. So if you ask me two questions, I'll forget the first one. So this is a good idea to do them one at a time. First of all, figuring out where to go to have these discussions is an interesting one. I think the UN is not an unreasonable place, but the Consultative Committee on Space Data Systems is another one. Although it tends to be focused on data communications, there's no reason why it couldn't expand its conversation to include a broader range of topics. I think, though, that it is something that the Internet Society should also engage in. After all, we're talking about an interplanetary Internet. Well, there's no reason why the Internet Society shouldn't be part of that. It has an interplanetary chapter already, which has been around since 1998. And so that chapter would be delighted to host conversations on these questions, but we would need ultimately to present the issues and maybe even some of the ideas to others who are in a position to adopt various and sundry treaties. So I would go not only to the Internet chapter, but I would also go to UN, COPUOS. I would go to the Internet Governance Forum. And in fact, we will have a session on the interplanetary Internet at the Internet Governance Forum that's coming up in June in Oslo. We have had such a discussion at the last Internet Governance Forum, last two actually, one in Japan and more recently in Saudi. So this is a big opportunity, I think, for all of the Internet Society chapters to engage and to bring their expertise and their ideas for how to shape the policies that are going to be needed as we expand into the rest of the solar system.
Oh, thank you. I would really like to reach you out for this resource too. Second query is like I'm trying to establish a digital peace state, because I come from one of the remotest area of India, where I have seen the marginalized society getting affected by the ineffective uses of mobile phones. Their psychological behavior has changed in some respect. The cybersecurity issues they are facing, the financial crimes they have faced. So I have tried to solve for many people at a pro bono basis, but currently I look that there are side effects at a very minimum level. But yes, there are for this marginalized society who do not get the upper hand of help, maybe through consultancy or anything. So I'm trying to establish this awareness campaign. So again, I would like to write it to you for the encouragement and support. Additionally, again, my same question repeats, that to whom to reach, because I tried reaching you and I haven't got much acknowledgement from them, but I'm trying to take it to different policymakers. But what more can I do to it?
Well, first of all, let me show you in the chat how to get a hold of me. I'm Vint at google.com. That's assuming I can actually spell, right? There we are. So if any of you want to reach me, that's a good email address to send me, and I'm pretty good about responding to email. If I've missed yours somehow, I apologize, but please do try again. Second, the access to the internet, of course, is not just a question of physical connectivity. You have to have some idea of how to use it. And of course, in different parts of the world, you'll find people using different equipment. Some people are more commonly use laptops and pads. A very common use, as you imply in your comment, are mobile phones. All of these systems have vulnerabilities associated with them. And it's particularly harmful, I think, when you introduce these technologies and these applications to a population that is unfamiliar with the technology and with the environment, the ecosystem in which they're working. They are more at risk for a variety of reasons, perhaps less experienced, for instance, and therefore potentially vulnerable to phishing, as an example, or to other kinds of attacks against the system. I have to say that, that one of the big challenges we have is the ubiquity or increasing spread of mobile phones has created a dependence on them, which I worry about a great deal, because if we build a layer upon layer of dependence on that device working at all times, and it doesn't work all the time, then you get cascade failures as a result. A silly example of this might be where you have a particular application on a cloud somewhere, which is helping you run your company, but your company CIO knows that two-factor authentication is important. And so the way you get connected to your company's application is to log in and then use the mobile phone for a second factor where it says, please enter this passkey, or please type the number that I just sent to you. Now, let's suppose your mobile phone isn't working because you didn't get a signal, the battery is broken, or you sat on it and you broke the phone. Now you can't get into your application. And that was the one day when somebody was going to send you a bid for a big piece of business, and you can't respond and you lose the business and your company goes bankrupt. Now, I know that's kind of a silly example, but it's the kind of scary thing that can happen when you have a heavy dependence on one thing working all the time. So I'm very concerned about things like that. I believe that we should have more resilience in the architectures of our systems. And if we are saying to people, come and join us on the internet, it's a great place. You'll be able to enhance your ability to execute your business. You'll learn more. You'll be able to find new friends, all of which is true. But we also should be saying, by the way, this is not a risk-free activity. Just to be a little extreme about this, from time to time, I have suggested, with a smile, that we should have an internet driver's license. And the point here is not literally that you have to get a license to get on the internet. But here in America, anyway, before we let teenagers get the keys to the car, we say you have to go through a class about driving, and you have to demonstrate to us you know what the rules are, and you can demonstrate you can actually use the car safely. The same argument might be made for the internet, where we could say, listen, we want you to get on and use it, but you need to show that you know what you're getting into. And so please demonstrate to us that you've learned what the risk factors are, you've learned how to defend yourself, you know what two-factor authentication is, you know what phishing means, you know not to give away personal information indiscriminately. And only after you demonstrate that do we issue you your driver's license so you can get on the internet.
Okay, thank you, Vint. I got myself. I'll just mail you up. Okay, thank you.
Yeah. So Vint, just wanted to ask, you have some time? Can we take a few more questions from the audience? They're all
yes, we can. I allocated an hour for this, so we still have 20 minutes.
So there are two questions here from two different people, Divya and Tarun, and I'm just kind of merging that question into one question. Essentially, they want to learn about how your future internet communication protocols will navigate with challenges of latency, delay, and other things, especially when you're establishing colonies in Mars or, for interplanetary communication. So how can they get introduced to, this evolution of DTN networks in case if someone is interested?
Okay, so, well, the first thing we thought about was doubling the speed of light. And then Mr. Einstein said, you can't do that. So we said, okay, so we threw that away. So basically what we concluded is that we will use communications the way we have for the last multiple decades. We'll use radio communications. We will use lasers when they are available. And there's been a number of very successful tests with laser-based communications in space. The latencies we can't do away with. We have to live with them. So the protocols are latency aware. That's why we call it delay and disruption tolerant networking. We will use this layered protocol suite. We use point-to-point links that might be running a variety of different link level protocols. One of our new ones is called the Licklider transmission protocol. And those are designed to have acknowledged transmissions, orderly delivery, forward error correction, and a variety of other things to make the channel more reliable. The other thing that we do, as I mentioned in my remarks earlier, is that the forwarders, the routers of the interplanetary system can actually hold data, can hold the bundles until it's possible to transmit them to the next hop, and rather than throwing things away, which is what we do with the routers and the internet. And so it's the storage in the network, which is a new idea. And the only reason it's feasible is that memory costs have gone down dramatically from when they were in the 1970s, when it was a lot more expensive. So storage in the network is part of it. We also are very cognizant of the problem we have with mapping of names to addresses. And so the DTN design doesn't work very well across the interplanetary system. What we are expecting will probably happen is that local internets may be built on Mars, for example, or on the moon, or in a spacecraft. Local TCP/IP or UDP, quick over UDP protocol internets will be present on spacecraft and on sites on the various planets. But we will use the bundle protocol suite to transport the data back and forth between these local internets. So we won't be running TCP/IP across the solar system. We'll only be running it locally, which is what we know works here on this planet. We'll use the bundle protocol suite as a way of relaying information back and forth between these very distant communicators. So that's the roughly speaking, that's the plan for making use of the two kinds of protocols, the terrestrial internet ones and the interplanetary bundle protocols.
That's very helpful and interesting. I'm again, going into the chats and getting some questions from there. So one question has been posted by Dr. Sivaramakrishna. He's saying that, are there any open collaborative projects or initiatives where students or researchers from India can contribute to interplanetary internet research?
Yes, indeed. There are two things. First of all, for people who really want to dig in, there is a project working group of the Interplanetary Network Special Interest Group. If you go to ipnsig.org and look at, you'll see invitations there for participation. So that's one possibility to actually get involved in implementation and testing. There's also something called the Internet Research Task Force, IRTF, and there are working groups within the research task force where students might want to engage as well. So those are two opportunities right off the bat. We do have, at least up until recently, at the Jet Propulsion Laboratory, there have been opportunities for students to engage and participate in development and testing of the interplanetary protocols. I'm sure those of you who are looking at the United States right now and scratching your heads, wondering what happened to us, I can't give you any assurance that the programs that have been supported in the past will continue to be supported. I hope so. So I would suggest that some students who are interested consider looking at the Jet Propulsion Laboratory as a potential place to do some research during the summer months, for example. But just be aware that a lot of our institutions are in a state of turmoil right now, thanks to the current administration.
Again, that's very helpful, Vint. We'll encourage our students to, keep a note of all the initiatives that Vint has mentioned and probably go and research on them. And anyways, if they have any queries, they can always reach out to Vint or us so that we can help you in your journey. Again, going through our chats, we have a question from Sabri, who also is a chapter president for ISOC Trivandrum. The question seems to be a bit technical. He's asking, Vint, please share your thoughts on handling security protocols to mitigating risks like replay attacks and quantum-enabled crypto analysis, given the inherent delays in interplanetary communications.
Okay, wow. This is a little bit like the final exam in the physics, astrophysics class that says, describe the universe.
So if you're there on the call, you can also come on the call as well. So if you're there on the call, you can just say hi to Vint for your question.
Yeah, hi, Dr. Vint. I'm Shabrinath. I work with the cybersecurity department at Kerala. So that's how I got into this question.
Okay, so first of all, we do incorporate high security mechanisms in the bundle protocol suite. We use public key cryptography as a way of exchanging symmetric keys. One thing we are well aware of is the quantum computing threat against the current crop of public key crypto. The National Institutes of Standards and Technology here in the US has adopted 4, maybe now 5 post-quantum protocols or algorithms for both digital signatures and for end-to-end exchange of encrypted information, digital signatures and the like. And so we will use those when they are standardized to defend against the quantum attack that everyone is worried about. No one has a quantum machine that can run Shor's algorithm right now, as far as I am aware. So it's not an instantaneous threat, but it will be a threat over time, certainly within 10 or 20 years. So we do care about that. We embed cryptography into the bundle protocol suite since the very beginning with the intent of verifying the identity of any of the parties that are exchanging information. So we want to know whether the source can be validated as a known source, and we use digital signature technology as a way of doing that. With regard to the use, I thought I understood you to be implying a question about quantum entanglement as a way of doing communications. Everyone seems to leap to the idea that if 2 entangled particles remain entangled regardless of how far away they are, does that mean we can do instantaneous communications in space? And the answer is no, because those entangled particles, first of all, it takes speed of light time for an entangled photon to get from Earth to Mars, so you don't overcome that. Once it's there, the only thing you can do is measure its state. And if you had in mind, for example, that you send an entangled photon to Mars and you keep the other of the pair on Earth, and then you somehow force the state of the one on Earth to force the state of the one that's on Mars, it doesn't work, because as soon as you force the state on the one on Earth, you destroy the entanglement. So the entanglement does not produce communication, unfortunately. So we have to put up with the latency that the speed of light imposes on us.
So we hope that answers your question.
Yeah, thank you. Thank you. It does give me a little bit more of the introductory part, which I will take on further. Thank you so much, Dr. Vint.
Okay.
And just for your reference, but Sabri heads our ISOC Trivandrum chapter. So he's also an ISOC chapter leader like a lot of us, but from a different chapter. Again, I'm browsing through the chats. One of our very young volunteers, who is probably in college now, has one question for you. Gungun is asking, could AI-driven autonomous networking play a role in making interplanetary communications more efficient? And would AI-operated relay stations help better manage data flow between planets? So there's a lot of talk of AI, as you're aware, even in Silicon Valley. So if you can just throw a bit of light on AI and network communications, how AI can be helpful.
It's always amusing to be having these kinds of discussions while the artificial intelligence boom is going on.
Yes.
It reminds me of the blockchain boom that went on perhaps 5 or 6 years ago. Artificial intelligence, machine learning, and large language models have shown their capacity to do some pretty amazing things. Setting aside large language models for just one moment and looking only at machine learning, or conventional machine learning, for certain kinds of applications where the statistical properties of the problem are known and measurable, you actually can get quite powerful results. To give you an example, weather prediction, which normally involves an enormous amount of computing trying to solve Navier-Stokes equations on large supercomputers, grinding away to make a prediction for what the weather is going to be over the next 4 or 5 days. It turns out that some machine learning models can build a foundational model based on 40 years of weather data, and then take the last 48 hours of weather as a context and then make predictions. It's astonishing how good those predictions are and how quickly we can produce them. In other words, you don't need nearly the same computational power as you do for doing a full-up weather simulation. So AI, or at least machine learning, can be helpful in some contexts. With regard to the interplanetary situation, I think we don't really need AI for the communications part. Most of the time, we can figure out where things are going to be and when, because of celestial dynamics and our ability to predict where things will be based on their trajectories, whether they're in orbit or maybe in transit from one place to another. So those computations can be done and extended over a period of time, and you build what's called a contact plan that will tell you when various of these spacecraft and these locations on the planets or the moons could communicate with each other. And then you build a model of that, and you create a collection of contact plans that allow each of the devices, each of the end nodes, to know when they should be transmitting between themselves and other parts of the system. So I don't think AI is necessarily going to help there. It will help, however, when we finally get to go on landing on the moon and building laboratories and the like. The use of AI for analyzing the data that we're getting from our experiments could be very powerful indeed. And even some of the earliest history of artificial intelligence involved the moon rocks that were returned from the moon in 1969. They were using spectrographic analysis to try to figure out what materials were in the moon rocks, and they were using sort of an artificial intelligence. It wasn't anything like the large language models, but it was using heuristic programs in order to figure out, based on the spectrographic signature, what kinds of materials might have been in those moon rocks. So there may be a place for AI here, but it probably isn't needed for communications.
Thank you, Vinton. One last question, before we move on to our vote of thanks. Now, this question I've got as a text, kind of a very eccentric question, but I would like to ask you, what has been ISOC's take on multi-stakeholder governance in the interplanetary ecosystem? And do you envision extraterrestrials to also be one important stakeholders in that context?
So first of all, well, if you will allow me to say that the Interplanetary chapter represents the Internet Society's position on multi-stakeholder governance for interplanetary internet, because that's what we've undertaken as part of our objective. And so the answer is we're huge fans of that multi-stakeholder governance principle, and we express that regularly. I certainly have been arguing for that at the Internet Governance Forums, where I'm chairing the leadership panel for IGF. And now with regard to extraterrestrials, the non-human ones, I assume that was what you were implying. We have not met any of the Martians yet, and so we don't know what the Martian delegation is going to say about multi-stakeholder governance. But just to give you a kind of funny twist on your question, there's another project that I'm involved with that I started together with some colleagues in 2013 called the Interspecies Internet. It is all about trying to understand how non-human species communicate. And we look at the intra-species communication, whales, dolphins, bonobos, chimpanzees, gorillas, even prairie dogs, In ordinary dogs, we've been looking at a variety of intraspecies signaling. I want to be careful about the use of the word communication because it implies a great deal. We believe at the Interspecies Internet that there is a level of cognition in non-human species that we should appreciate. Now, when we got started in 2013, we were also asking ourselves, could we figure out a way to allow a whale or a dolphin to communicate with an elephant or a gorilla? The internet was thought of as simply a transmission medium, so that if these two species were not co-located, at least the internet could bring them together virtually. Since that time, we have also concluded that artificial intelligence may help us understand the meaning of intraspecies communication. And if we could understand what the whales are saying, or what the dolphins are saying, and what the elephants are saying, we might be able to use the internet and its artificial intelligence powers to translate what the elephants have to say into something that the dolphins will understand. At this stage, I mean, that is still science fiction. But we have increasingly been able to use machine learning models, at least to try to understand the context in which signals are generated by specific species. So maybe when the Martians show up, we can make use of the interspecies internet facilities in order to engage with the Martians so they can participate in the multi-stakeholder governance discussions.
That's very helpful. And I think that's a very interesting term called as interspecies communication. I think that is a new term that we would now like to add in our understanding of internet per se. Many questions per se, but coming back, I think we will take, all these questions probably we will mail to Vint and, get back to you, because I understand Vint is, a bit tight on time. So Vint, I understand you, or would you still take a question or a more? Because
no, I need to stop now because I had an hour allocated for this. But could I make an offer? I know there are many questions that showed up that we didn't answer. You have my email address.
Yes.
If those people who asked questions would like to forward them to me, I will try to respond to them. Most likely what I will do is do a video. I will take the questions, I'll say what the answers are, I'll forward the video to you, and then you can share that with the chapter.
So we'll just ensure that we get your email ID. I think probably only the host has got it, but we will, share it with the participants. We'll now move on to the final session of it. So Nupur, over to you. For vote of thanks to Vint.
Thank you. So first of all, I would like to tell you that I don't have his email because it's not showing up on the chat somehow. But yes.
We'll request Vint to again type in your email. By the way, we give you a vote.
I'll put it in again. It's easy enough. It's just Vint, V-I-N-T, at google.com.
At google.com. Okay.
I'm pretty easy to find.
Yeah. Perfect. Yeah.
All right.
There.
Thank you.
Did it get in?
Yes.
Yes. All right. Thank you. Thank you so much, everyone. I would like to extend my deepest gratitude to Dr. Vint Cerf for graciously joining us today and sharing his visionary insights on the future of interplanetary internet communication. Dr. Cerf, your lifelong contributions to the world of internet and technology and your continued work to expand the boundaries of human connectivity beyond the Earth are nothing short of extraordinary. I will also like to thank Scott Berkeley. I would also like to thank Caitlin for her seamless coordination, Jolly for managing the live stream, Sohini for facilitating the communication with Mr. Cerf, Mr. Mark for actively promoting the event, and also Vinayak, Firoza, Joysha for the stunning flyers, Prateek for moderating the session, Valentine for the steady support and communication throughout. Also to my fellow leaders, Joysha and Jigmit, for their unwavering support and dedication. I'm also deeply grateful to our advisors, Shwetananta and Prateek again, and for their constant guidance, and to each and every volunteer of our chapter, that's ISOC India Mumbai. And without them, this event would not have been possible. I would also like to extend a warm thanks to Cheryl, Humayu, Brajesh, Jain, others, Savrish, Minnie, and other friends of ICANN and ISOC. And at last but not the least, I would thank you to everyone who has joined, and thank you all for making it memorable and a meaningful experience. Thank you all.
But just one thing, we'll have a photo session, Ben. So just a minute. We'll
Yeah.
just request all of you to switch on your cameras for one last photo.